Now, before we get into the actual formal lecture for the section coming up, I want to just have a bit of a time to talk to you about a moment. So let's say I've got two moments going the opposite direction, like if this is like a steering wheel or something and I'm trying to turn it. I've got a couple of options here. Let's say I'm going to make the assumption right now that both of these forces are always the same. So let's say that this is 10, whatever. Actually, I'm going to make them go the opposite direction because then we'll always have positives. So let's say it's 10 newtons going left and then 10 newtons going right here on the bottom. And let's say that they're a distance 3 from the center. Okay? I can say that the moment produced by this force is 10 times 3, and it's counterclockwise, so it's positive. So I can say that this is plus 30 Newton meters. Okay? Likewise, I can say the moment created by this force is 10 times 3, about 0.0, again, about 0.0, is 10 times 3, and again, it's a counterclockwise direction, so 30 Newton meters. So the resultant moment is the two of them, which is 30 plus 30, so 60 Newton meters in the positive direction, right? So I've got perfectly content doing this. Yes? Okay. So I'm going to make this a little smaller so I can play with it. Okay. So now let's pretend instead of that, let's say I still have the 10 this way and the 10 this way, but instead of finding the resultant moment about O here, let's pretend that O is here. So we've still got 10 and 10, but now this distance is, say, 5, and this distance is, no, that wouldn't be 2. This distance is 1, right? So the total distance is still 6. The distance here is 6. So the total distance, nothing's changed. I'm just taking the moment about a different point. All right, so the moment here would be m equal to 10 times 5. So that's 50, positive 50. And the moment caused by this guy would be 10 times 1, so positive 10. So the resultant moment would again be 50 plus 10, or 60 Newton meters, which is the same thing I got before. Okay, so now let's try and say, well, what would happen if I took the resultant moment about 0.0, but I put 0.0 right here? All right, so this distance is 6, and then I've got 10 and 10. Well, the moment caused by this guy is 10 times 60, right? The moment caused by this guy is 10 times 60. The moment caused by this force, though, is 0 times 10, right? Because the perpendicular distance is 0 because it's sitting there right on the axis. So that moment's actually 0. But the resultant moment, check this out, is still, I can't multiply. There we go. The resultant moment is still 60. Now here, I'm going to do something totally crazy. I've still got 10 and 10, but I want to take the moment from a point up here. So let's say that this distance now is, I don't know, 3. So that makes this distance here, plus the original 6, 9. All right. Now the moment created by this force is 10 times 3, but it's clockwise, so it's in the negative direction. So that moment is actually negative 30. The moment caused by this force is still going to be counterclockwise, so it'll be positive, but it's 9 times 10, which is negative 90. So now when I add these two moments, positive 90. So now when I add these two moments together, I still get positive 60. So what we're going to look at here in a sec is the idea that if I have, so I'll just go ahead and characterize the whole lesson for you. If I have two forces with equal and opposite direction, equal in magnitude, So equal magnitude, the opposite direction. Love my handwriting. They, with an A, really? They will create a moment basically, if I call the force F and the distance between them D, so if F is the magnitude of their force, one of the force's magnitude, since the magnitudes are the same, equal to F times D times the distance between them, right? That's what we got every single time. The force times the distance between them. And this moment is independent of where you're taking the moment about. So this is actually what we call a free vector. So keep all this in mind as you watch the next couple of lecture videos, because this is basically what we're talking about. So I can prove it to you numerically very, very quickly, and then we'll prove it algebraically, because again, this is a Cal-based course. You need to understand how to prove things algebraically so you know what assumptions go into it, so that eventually you don't apply the right equations with the wrong assumptions, blah, blah, blah. So it's really important that you can derive all this so you know where it comes from. But the essence of what we're getting at is if I have these two forces, it doesn't matter where I take the moment about, because no matter where I take the moment about, I'm going to get the same answer, which is just absolutely fascinating.